Q8113. The blending of blades and vanes in a turbine engine. A. Is usually accomplished only at engine overhaul. B. Should be performed parallel to the length of the blade using smooth contours to minimize stress points. C. May sometimes be accomplished with the engine installed, ordinarily using power tools. The correct answer is B. Damaged compressor blades and vanes can be manually reshaped using small files, emery cloth, and honing stones by blending. To reduce stress accumulations and restore a smooth shape to the surface, blending is done parallel to the length of the blade. Q8114. What turbine engine section provides for proper mixing of the fuel and air? A. Combustion section. B. Compressor section. C. Diffuser section. The correct answer is A. In a turbine engine, the combustion section is the section responsible for proper mixing of fuel and air. It is within the combustion section that the fuel is injected and mixed with the compressed air from the compressor section, resulting in the combustion process. The combustion section is designed to ensure efficient and thorough mixing of fuel and air to facilitate combustion. The fuel is typically injected through fuel nozzles, and it mixes with the high-velocity air from the compressor. The fuel-air mixture is ignited, resulting in the release of energy and the generation of high-temperature and high-pressure gases. The proper mixing of fuel and air in the combustion section is crucial for efficient and complete combustion. It helps achieve optimal fuel utilization, which leads to improved engine performance, power output, and fuel efficiency. Q8115. In a gas turbine engine, combustion occurs at a constant A. Volume, B. Pressure, C. Density. The correct answer is B. The combustion process in a gas turbine engine takes place in the combustion chamber, where fuel is mixed with compressed air and ignited. During combustion, the fuel-air mixture undergoes a chemical reaction, resulting in the release of heat energy and the generation of high-temperature and high-pressure gases. The combustion process is typically designed to occur at a constant pressure. This means that the pressure within the combustion chamber remains relatively constant during the combustion process. The constant pressure allows for consistent and controlled combustion, ensuring stable and efficient engine operation. Q8116. Which statement is true regarding jet engines? A. At the lower engine speeds, thrust increases rapidly with small increases in RPM. B. At the higher engine speeds, thrust increases rapidly with small increases in RPM. C. The thrust delivered per pound of air consumed is less at high altitude than at low altitude. The correct answer is B. The relationship between thrust and RPM is such that the amount of thrust increases rapidly as the engine speed increases. A small change in speed at low RPM will not produce nearly as much increase in thrust as the same amount of change at high RPM. Q8117. Some high-volume turboprop and turbojet engines are equipped with two-spool or split compressors. When these engines are operated at high altitudes, the A. Low-pressure rotor will increase in speed as the compressor load decreases in the lower density air. B. Throttle must be retarded to prevent overspeeding of the high-pressure rotor due to the lower density air. C. Low-pressure rotor will decrease in speed as the compressor load decreases in the lower density air. The correct answer is A. The speed of the high-pressure rotor in a two-spool, split-spool, compressor is controlled, while the low-pressure rotor operates independently at its optimal speed. At higher altitudes where air density decreases, the compressor load reduces, causing the low-pressure rotor to accelerate.